Hello, my name is Harshal Pawar and here is my ID. Yeah. In question 3.1 and 3.2 and 3.3, we will be demonstrating a stateless firewall rules using IP tables on Linux. A firewall is a network security system that monitors and controls incoming and outgoing traffic based on the predetermined security rules. The Linux has an inbuilt framework called netfilter, which can be configured using IP tables command. IP tables works by defining rules in chains. There are three main chains. Input controls incoming packets destined for the router itself. Output controls the outgoing packets originating from the router, and forward controls the packet passing through the router. Each rule specifies conditions to match and an action to take, either accept, drop, or reject. In this demonstration, we'll be implementing two firewalls. First, question 3.1, we will prevent the router from pinging IP address 1, which is 7.7.2.4. That is the last four digits of my student ID number, by blocking outgoing ICMP echo request. In the second question 3.2, we'll prevent ICMP echo replies from 8.8.8 from reaching to the router by blocking the incoming ICMP echo replies. Our network informant will be including three most important parts: the seed router, the host, and the internal host working on the network. First, let me verify if all the Docker containers are running. So let's just go to cd downloads. Yes, ls. Let's go to now. Yeah,
Here's
see
what I found.
labs setup firewall.arm ls cd lab setup arm ls. Okay, let's verify if the Docker containers are running. Yes. Uh, Now we can see all the Docker containers are running. I'll enter the router container where we'll configure the firewall rules. So docker exec/it seed router /bin/mesh. Let me first show you the current IP tables rules before we add anything. So IP tables /ln v. Yeah, we can see all the three chains: input, forward, and output. Currently, default policy is accept without no rules. This means all the traffic is currently allowed through the router. Now let's test our ping to IP1. So for 3.1, we need to ping my last four digits of the student ID, which is 7.7.2.4. C3. Yeah, we can see the router sends three IP echo requests, uh, and but gets no replies because 7.7.2.4 doesn't actually exist on the internet. But we can see that the three packets are being transmitted here. Our goal is to prevent even sending of these packets. So now I'll add IP table rules to prevent the router from pinging into 7.7.2.4. So IP tables /a output p ICMP ICMP type echo request d 7.7.2.4 j drop. Along with this, I'll also explain what this command actually means. So yeah, the output a, like dash a output, appends the rule to the output. We use the output because we want to block the traffic leaving the router. Dash p ICMP match the ICMP protocol. Dash dash ICMP type echo request specifically matches the ICMP echo request package, which are type 8. This packets sent when you run ping. Uh, like dash D 7.7.2.4 only matches the package distance for 7.7.2.4, which is our IP, and J drop silently drops the matching packet without sending any error back. So let me verify if the rules were added correctly. So IP tables output dash L output, sorry, output dash N dash V. As we can see, the new rule of output chain, it matches the ICMP type 8 echo request package distance for like 7.7.2.4. Now let me test the rule by pinging to 7.7.2.4 again. So ping 7.7.2.4 dash C3. See, we can see the ping message operation not permitted. The router cannot even send ping packets now. The firewall rule is blocking the outgoing ICMP echo request at the output chain before they even leave the router. As compared to the rule before, we saw the packets are transmitted. Now the packets transmitted are 0. uh, Thus we can conclude the protection is working correctly. For question 3.2, we need to prevent the ICMP echo replies from 8.8.8.8 from reaching the router. Let me demonstrate that the router can currently receive pings from 8.8.8. So let me just 8.8.8.8 and dash C3. Yeah, we can see three packets are transmitted, three packets are received, 0% package loss. The router is successfully pinging 8.8.8.8 and receiving replies. Our goal is to block those incoming replies. So now I'll add the IP table rules to the ICMP block, to the block for ICMP echo replies from 8.8.8. So tables, IP tables dash a input dash p ICMP dash dash ICMP type echo request 8.8 point, sorry, as we can see it's a reply, as we are blocking s 8.8.8 8.8 dash j drop. So let me explain this rule. Dash a input is appending this rule to input. We use input because we want to block the arriving traffic at the router. Dash p ICMP is like match the ICMP protocol. Dash dash ICMP type echo reply specifically matches the ICMP echo reply packets, which are type 0, and this reply packet sent back when the ping is received. Later we write dash s 8.8.8 only matches the packet with the source IP 8.8.8, and as we all know, dash j drop silently drops the matching packets. So yeah, let me verify if the rule was added correctly. IP tables dash L input, input dash N dash V. Yeah, we can clearly see the new rule is in the input chain and it matches the ICMP type packet 0 from the source 8.8.8 and drops them. Uh, Now let me test the ping on 8.8.8 again. So ping 8.8.8.8 dash C3. Yeah, just wait for a sec and we'll have our output. Yeah, we can see three packets are transmitted and zero received. 100% packet loss. The router is still sending ping request to 8.8.8, but replies are being dropped by our firewall before they even reach the router. This is very different from question 3.1. In question 3.1, we blocked the outgoing traffics, so they never left the router. In question 3.2, it's actually we are blocking the incoming traffic, incoming packets. The ping requests still leave the router and 8.8 still replies, but those replies are dropped by our input rule before the router processes them. So let me show you all the firewall rules we have configured. iptables dash L dash N dash V, sorry, dash V. Yeah, uh, as we can see here, input chain drops ICMP echo replies from 8.8.8. Output chain drops ICMP echo request from 7.7.2.4. These are stateless firewall rules. They only match individual packets based on their header fields without tracking the state of the connection. And here, every packet is evaluated independently against these rules. In order to summarize this, the rule iptables dash a output dash p ICMP dash dash ICMP type echo request dash d 7.7.2.4 dash j drop prevents the router from pinging request to 7.7.2.4. This protection against the router is being used to probe or communicate with what specific external host. Uh, After adding the rule to the router gets operation not permitted when trying to ping 7.7.2.4, these packets never leave the router. And in question 3.2, the IP rule IP tables dash a input dash p ICMP dash dash ICMP type echo reply dash s 8.8.8.8 dash j drop prevents ICMP echo replies from 8.8.8 from reaching the router. This could be used to prevent ICMP based attacks or like to block responses from a certain external server. After adding the rule, pinging 8.8.8 result is 100% packet loss. The requests go out, but the replies are silently dropped. This both rules demonstrate the power of IP tables, stateless firewalls. With simple one-line commands, we can precisely control what traffic the router can send and receive, providing the granular network security protection. So, thank you. That's all.